Hi Shady, hi Benjamin, hi Payam, hi Maike, welcome.
Hi.
Hi,
Hi
Dear,
everyone. Hi, Prof. Serdar.
thanks.
Hello.
Thanks. Hello. Dear ladies and gentlemen, welcome to the session 525. This is the last session of the Zero Build Forum. The theme of the session is Achieving High Quality in Zero Energy Buildings. I am Professor Serdar Ulubeyli. I am a member of the International Board of the Forum. In this session, we have 4 speakers. The duration is about 100 minutes. Each speaker will speak about 20 minutes, and after that, lastly, we will have 20 minutes again for questions and answers. Although I will introduce our speakers briefly before their speech, you can see their LinkedIn profiles in a detailed manner by clicking their names in the program page on our website. Now we are starting the session by a speech from Assistant Professor Shady Attia. Shady is a member of the Forum's International Board. He is currently working at the University of Liege, Belgium. His research focuses on the building performance in the architectural context in general and the use and optimization for decision support of sustainable buildings in particular. Shady is the author of 2 books. The first one is Regenerative and Positive Impact Architecture, Learning from Case Studies, and the second one is Net Zero Energy Buildings, Concepts, Frameworks, and Roadmap for Project Analysis and Implementation. He has also provided consultation and technical support for LEED projects in Belgium, Egypt, Jordan, Morocco, Switzerland, and Djibouti. Now the title of his speech is The Best Practices of Quality Assurance for Net Zero Energy Buildings Design. Yes, Shady, ahlan wa sahlan to our forum and the session. We all are willingly waiting for your address indeed. It's your turn.
Thank you very much. Can you hear me?
Yes.
Okay, I will share screen. So, can you see my screen?
We will see now.
I will check again just to make sure I'm sharing my screen properly.
It will take a few seconds.
Okay.
No.
Is it fine now?
It's coming. Yes. Okay, you can start.
Okay, so good afternoon, everyone. Thank you, Professor Serdar Ulubeyli, for this invitation. I'm honored to join the Zero Build Forum 2020. And I'm going to talk today about the best practices of quality assurance for net zero energy buildings design. Well, I was introduced. My name is Shady Attia, and I work in Liege University in Belgium. Now, before starting, I would like to share with you some basics to make sure that we are on the same page. When I'm talking about net zero energy buildings, I'm talking about buildings that are grid connected. They are highly energy efficient, and they are buildings that can balance the total annual energy consumption through renewables on site. So this is the first statement to make sure about. There is another definition for nearly zero energy building. In this sense, buildings are almost achieving this goal, and therefore we distinguish the nearly zero energy building from net zero energy buildings. Net zero energy building, they must have a neutral balance on an annual basis. Well, to get you further on in the definition, we are talking here about an approach of net zero energy building, or a definition that is quantifiable, and it is based on a universal metric, which is the Site Energy Use Intensity metric, the EUI. And in this sense, what we try to do, we try to measure the total energy consumption at the end use for lighting equipment, cooling, pumps and fans, heating and hot domestic water or hot water in general, depending on the building type, and function, and we divide it by the gross building area in order to get an estimation of the total energy use intensity. And depending on the renewables production, we should come up to a zero energy balance. Now, some other countries, they define net zero energy buildings based on a primary energy use indicator. In this sense, the main difference will be that we have to look at the energy sources, the losses, transmission, delivery, and production, and we will do the same exercise of calculation, however, at the source of the energy generation. Now, when we look at this definition of net zero energy building, it's based on principles of high performance building design, and we are looking at three major principles, which are the trias energetica, mainly to diminish the energy losses, use sustainable energy sources, and finally use fossil fuel as efficient as possible. And these are the principles that can guide us, take us towards first energy neutral buildings, and finally we hope to reach also carbon neutral buildings. Now, in order to get into the challenges of net zero energy buildings are almost more than 10 years now present on the political agenda of many countries. And when we look at the challenges facing those type of building, we find that in the European Union, also in the United States, there's a kind of type of certification. In Europe, it's the energy performance certification. And as you can see, this is an example of where we are today regarding the formalization of net zero energy building. We are creating certificates to assess the efficiency of buildings. And as you can see, this is a case studies where a building on the left side, it has a gas boiler and photovoltaic, and some basic energy efficiency characteristics of the envelope is having a higher grade of C compared with a building that has a gas boiler and a good envelope. So it's very important to take care of these regulations and how we are implementing them, because that's not the purpose. If we see this result and compare it with the basic rule of trias energetica of diminishing energy losses from the beginning and investing in efficiency, we find here that we have a kind of confusion, and we are confusing the market by not putting priority where should we invest in energy efficiency of the building, and then should come renewables. Another examples of where we are today, when we look at net zero energy buildings, the energy performance certification, they penalize net zero energy building with clean heating. You can see on the left side, this is a gas boiler, and on the right side, we have a heat pump. And the gas boiler building has a higher certification or an efficiency indicator. And again, this is very dangerous, because if we are looking to have a higher electrification rate for Europe, for sure we will have an energy mix. But if we want to get off carbon, we will need to abandon fossil fuel and gas. And in this sense, a heat pump coupled to a renewable system can be much more effective and much more environmental friendly. And this is a debate that we are currently having in the European Union. So let's go further on the challenges that we are having and facing today. When it comes to the design of these high-performance buildings, we are in a transformation phase, and those are new design practices that many offices and architects and designers, building professionals are not aware about. We have problems with large window-to-wall ratio, as you can see in this facade. We have a lack of external shading. Many people are underestimating the solar radiation. We have inoperable windows in many net zero energy buildings, and these are all problems, and we are unable to place properly the low emissivity layers, depending on the cooling dominated or heating domination of the building. And this is also a cause of confusion for many designers. And finally, we have an overestimation of night cooling in different net zero energy buildings. When we look further on the design quality of net zero energy buildings, we can see also that many designers are unaware of the importance of high ceiling height, and under the pressure of cost, under the pressure and the ignorance of reduction of the heated spaces or the mechanically cooled or mechanically heated spaces, many designers just simply reduce the overall ceiling height, which is very negative in the overall performance of buildings. There's undersizing of mechanical ventilation system and ducts, and we are underestimating the importance of having sufficient flow rates to assure air quality in buildings. And under the pressure of energy efficiency, we jeopardize in many cases thermal comfort. And definitely acoustic problems are also associated with the new installation of fully mechanically ventilated net zero energy buildings. So these are all examples of issues related to design qualities that most designers are encountering based on cases in the last 10 years. Now, when we look at the construction sites, again, there is an issue because we are in a transformation market. All suppliers, all contractors, all subcontractors, they need to learn about how to protect the heated or the mechanically cooled spaces, how to make sure that the buildings are compact, and how to prevent leakages through air tightness and perform a blower door test in a systematic way while sealing all potential leaking cracks or openings. So this is also a very important measure of quality that we are finding that the uptake of the construction market or the construction industry is facing challenges in this regard. This is another example. We are talking today, it's not a surprise, future buildings and even existing buildings that will get renovated, by default, they must be highly insulated. They must have a good air tightness indicator. And as you can see, if we are going to place the insulation without any proper consideration of the quality of the insulation, we are losing millions of euros or dollars or whatever currency we use and just beautifying the process of design and construction, while in reality this should not be the case. We should implement insulation properly, and this will require a higher supervision from site engineers and better education and vocational training for technical and workers on sites. Another example we are facing a lot also in net zero energy buildings after implementation. There is poor implementation of insulation, as you can see, poor air tightness problems, and the difficulty to achieve the requirement of low air tightness, for example, infiltration rate lower than 0.6 air change per hour under 50 Pascal pressure. And as you can see, another example here in the coming slide, when we do investigative or destructive testing for envelope, we figure out that there's even condensation problems and lack of proper gluing of the different insulation elements. Another example you can see here that when we dismantle the very famous ethics, most probably ethics will be the most common envelope technology that will bridge us for the coming years. Ethics are external insulation construction systems, and they are mainly based on gluing big parts of insulation on the internal walls. But you can see that in many cases, under the fast construction and the fast pressure of competitivity and cost reduction, they end up being not appropriately implemented and placed on the insulated or the expected insulated surfaces. So these are all kind of problems that the industry is facing regarding design, regarding construction, and therefore we need to focus more on the quality and the design of net zero energy building and try to extract more learned lessons. So let me share with you some learned lessons related to this matter. Well, we have serious design quality issues. The market is facing a transformation resulting in trial and error approaches. Unfortunately, the trial and error approaches are the most common human mistake that happen in the industry, in the architecture, engineering, and construction industry. There is competitive pricing practices that encourage design teams and contractors to reduce or eliminate design solutions, which is in this sense is totally damaging by taking out, for example, shading or abandoning testing air tightness and so on. And for sure, there is a lack of expertise regarding the design and construction teams, and many consortia are built and formed without any investment in prior knowledge before endeavoring such high performance buildings. Now, when we look also to other learned lessons, well, there is big under a capitalistic approach where we are operating today. It's very difficult to switch the mindset of many design teams and tell them that you can really influence the factor of cost by working on different types of parameters. Actually, the choice of the construction technology, whether it's a bearing wall system or a post and column system, is it a steel construction or a concrete construction or a timber construction or a hybrid between those systems, it can significantly influence the cost. So instead of chasing quality and reducing the quality under the pressure of cost, design teams can early on select strategically construction technology that can give them margins with their budgets and then allow them to assure quality during design and implementation. Also, the choice of design envelopes, as you can see, the second graph, can influence the cost can increase it up to 13% or decrease it up to 7%, depending on the choice of your envelope technology and design. Construction and structural system can vary significantly up to 20% reduction of cost up to positive 27% increase of cost. So the choice of your construction and structural system should be taken into account as a firm or as a consultant. And also the choice of HVAC and renewable energy systems design has a significant influence ranging from plus 22% to minus 15%. And finally, the most influential factor on cost of net zero energy building is the project delivery type. Is it a design build a process? It will be very expensive. Once you go for a design and build process, you can significantly reduce the cost because early on the contractor, the implementer of the building, will get together with the design team and they will be able to make a lot of shortcuts and reduce the cost and make informed decisions that will allow them to reach the targets without having a high budget or extra cost for these buildings. So this is a very important lesson here. And as you can see, the more you invest in a net zero energy building, keeping into account intelligent project delivery type and a good partnership between the client and the design team and the construction company, the more you can invest in architectural features, reduce the cost of the delivery method, reduce the cost invested in HVAC system compared to conventional system. And therefore, these are one of the 5 major parameters that we learned from practice that we can influence as designers and contractors or the construction engineers in order to make sure that the buildings are kept under the same cost budget compared to conventional buildings while maintaining a high quality for net zero energy buildings. Well, what else learned lessons could we distill from the experience? Well, introducing design and construction reviews is one of the learned lessons. On the moment that a company is aware and conscious about the complexity of these buildings and how they require to have a phase of quality assurance after design and after construction, directly the quality of these buildings are significantly or remarkably even improved. Learned lesson also are inciting that we simplify the building services and automated solutions and try in this sense to simplify overall mechanical systems and integrate them with the HVAC system and introduce simple overriding automated solutions without complexity and use basic control technology that users are familiar with. We should not forget that people who will use net zero energy buildings, most of the time, they come from a domestic reality or they live in domestic houses where they are used, for example, to use a thermostat, just a movable thermostat, manually movable thermostat. There is no shame at all to introduce simple control technologies that users are already using in their homes and introduce them in net zero energy buildings so that we can make sure that operation and occupancy will not face major failures. And finally, simplify the building management automation systems. It's very important to avoid black box BMS or BAS because at the end of the day, it will be the user, the facility manager who would like to go back and fetch an algorithm and change the assumptions of the algorithm based on feedback coming from occupants after occupancy. So it's very important to keep the building management systems and the building automation systems open access, simple to manage with simple algorithm, what-if scenarios that later on facility managers and occupants, based on feedback and real use of building, can override these pre or during the design phase set algorithm and criteria. So these are 4 important learned lessons that we also can distill from our experience monitoring and doing post-occupancy evaluation for several net zero energy buildings in the last 10 years. Now, I would like to close my presentation with some best practices hints in order to assure and articulate better what I wanted to say. First of all, I advise design teams and construction companies to seek cost-effective approaches. They should look at delivery processes that allow for partnership from the beginning. The old linear design process of design, bid, and build is not able to work anymore in the context of complex and sophisticated high-performance buildings. Design teams should be from day one all on the same table, including the owner, including the design team, including the construction company or the contractors or the subcontractors, and they must also include the owners or owner representative who will be potentially occupying buildings, and in this sense they can have cost-effective approaches. The second thing they should look at in general as best practices, any design manager or a project manager, assuring design reviews. Today, one of the biggest problems we are facing in the design and construction of net zero energy building, that they do not go through design reviews. Design reviews should be based on checklists that are checking all the elements properly, the use of dynamic building performance simulation early on to avoid any risk of overheating, look at the design comfort condition of summer, because net zero energy buildings by default, even in cold countries or heating dominated countries, they will have high insulation, they will be airtight, and they will have glazing. And this means that the risk of overheating will be high, and therefore the integration of external solar shading devices, whether manually operated or automatically operated, is an essential and crucial element that should be checked and prescribed when we do design reviews to make sure that buildings are not going to risk, and occupants at the end will have a good well-being, keep their productivity and satisfaction. The other aspect related to best practices should be looking at assuring construction reviews through prefabricated and construction standardization as much as possible. If we can do things or elements part of the building off-site, this can be a good thing to do, because we can assure off-site integration and quality and standard respect and compliance. And then when we assemble on site, we can start to do our tests like the blower door test, which is essential for any net zero energy building, standardization of thermal nodes details, whether for air tightness or whether for thermal conductivity. So these are all important aspects, and definitely we should look at investing in occupancy education. It's unbelievable that we pay so much money in buildings that are high-tech buildings, and then we do not provide minimum training, minimum interaction with users to make them familiar with the use of these buildings that are depending on passive and active measures and systems. So as you can see, in a long process of a net zero energy building design, construction, and operation, design reviews must be introduced, especially after the implementation documents, and design reviews can be done by expert consultants who are having experience and they are monitoring already net zero energy buildings, and they know what are the problems, especially in the context or context specific or climate specific regions. Every region will have its own problem, and seeking those local experts who are tracing and following building can allow us to understand if the building is appropriate or not before going to the construction phase. And then after implementation, we can have a second round of reviews, which is the construction review, which can be part of the commissioning process, but it should be done seriously. It should be done through measurement, and it should be involving third party. I always advise that design reviews and construction reviews should be implemented by third parties. Well, by that I end up my presentation. Thank you very much, and thank you for this generous invitation. Further details can be found in my book. It was already mentioned before. Otherwise, I'm open for any comments and discussion. I'm looking forward, and I'm looking also to listen to my colleagues who are definitely going to have an interesting input in this session. I invite you to keep tuned. Thank you very much.
Thanks really very much, Shady, for giving a quality-based perspective for net zero energy buildings. In fact, there's a serious difficulty in industrial practices in order to assure design quality, and accordingly the architectural design process is subject to many change orders. In this respect, your presentation has like the utmost importance to our listeners. Thank you.
Thank you.
Now we will follow a presentation from Associate Professor Payam Shafigh. Payam is a member of the Forum's International Board. He is working at the Department of Architecture in the University of Malaya, Malaysia. His focus is mainly on the research and development of concrete materials. He has received awards from ACI, namely American Concrete Institute. Also, Payam and I are among the academic editors of different international scientific journals of the same publisher. His presentation is now concerning structural lightweight aggregate concrete for energy efficient buildings. Yes, Payam, Selamat datang. Our participants are eagerly waiting for your speech indeed. Good luck.
Thank you, Prof. Serdar. I'm just sharing my screen.
Yes, we can hear you.
It's clear? I'm screening. Yeah.
Okay, we see it.
Okay, one moment.
Okay.
All right. First of all, thank you very much, Prof. Serdar and the team and this forum. Very, very interesting topic and forum. Hopefully, it will be continue. And then, thank you very much for giving me this opportunity to share some of my my experience, and then can say my concern about the education, and come by my slide. My background is civil engineer. I'm working on the material, concrete material and structure, but structure can be related to somehow to the energy in the building. Just we go through maybe briefly now. When talking about the as an introduction, when we are the concern about urbanization and rapid development, usually the major concern is our resources, energy and environment. To take care of all these things, as a part of my expertise and my duty from my education and research, I am developing the lightweight aggregate concrete to be used in structure. And this structure material can be directly or indirect influence the sustainability in construction industry and energy usage in the building. Indirect is come up how can help the building and construction industry is significant reduction in the usage of the concrete and steel material in the final product. And as a direct, this concrete has low thermal conductivity, but at the same time has a good load-bearing capacity. Just I'm going to come up by these two direct and indirect ways. Let's come up to just a fast review about talking about the lightweight concrete. When we are talking about the lightweight concrete, there are different types. One, initially, when we talk about lightweight concrete, we remember some lightweight blocks, as you can see in these figures, we call it aerated cellular foam or gas concrete. All these type of the concrete are not load-bearing, and usually they are used for partition, filling the gaps and the voids, and they are very low density, and their strength is low, and usually are not using for the load bearing purposes. And another type of the live concrete is a type usually used for the pavement. In this concrete also the strength is low, but using for drainage, but the density of the normal concrete when is 2,400 kg per meter cube. This concrete is between 1,600 to 1,900. As you can see the application, for example, in this parking lot. But as an important type of the live concrete to be used for structure is a type of the concrete that this portion is, you see, the normal weight coarse aggregate will be these are the normal weight aggregate. This portion will be replaced by live weight aggregate. But what is the live weight aggregate? Live weight aggregate, there are different types. You can see here. We have a natural lightweight manufacture. Here you can see scoria and pumice. I think is available in Turkey also. This lightweight aggregate is agro waste from the palm oil industry. This is a palm oil fruit, and this portion is a lightweight. You can see as a shell. It can be used in the concrete, but it still is on research. It was not developed in the industrial scale. But another type of the live aggregate is has industrial use, is a lightweight expanded clay aggregate. It will be manufactured in the factory, and then of course there are a lot of the energy usage to produce it, and then it can be used for the planting. Maybe you can see in the plant and in the gardens. I am further introducing this aggregate. For one of the things for all this aggregate have the porosity is inside that make it to be lightweight. As an industrial scale of the using lightweight aggregate to be used in the concrete for produce load bearing lightweight concrete. You can see in this figure is a line of the Liege production, lightweight expanded clay aggregate production, and there are, as in general I explained, clay will be burned and some additive will be burned in this kiln for a temperature of more than 1,000 degrees. And finally, we have a different size of the aggregate here. So maybe initial thinking is to produce this lightweight aggregate, when such a huge amount of the energy and temperature is used, so how we can figure out it is sustainable. I explain in maybe another slide. Let me first, I come up by a definition, important definition about a structure like a concrete. A concrete to be used in a structure, meaning that in column, beam, slabs. American Concrete Institute is defined the structure like a concrete with a strength of more than 17 MPa and a density in this range. And we know with a density of something about 20 to 40% less than conventional concrete. And European Union also call it CEB FIP is has another definition, but meaning that a standard already went through to define the structure concrete for engineer to be easily used in the structure, and they are designed. But as the main application of the structure like a concrete is to decrease the dead load of the concrete structure, mostly in the high-rise building and long span bridges. If we apply this concrete in this type of the structure, we will have the significant reduction of the size of the piers, footing, walls, and other load-bearing elements, and in the foundation. using the structural lightweight concrete, that nowadays it is considered as a special concrete, and those can apply this concrete as expert. But this concrete was used in Roman engineers. By Roman engineers, for example, you see here is a large span domes because of to reduce the cell weight. And in Malaysia here, we have a city, a beautiful city, Melaka. I visited last year. I found this church was built in 1560, a long time ago. But as the structure of this church already there. One of the reasons is being there and still can function is they use the lightweight blocks, as you can see here, lightweight blocks. These lightweight are available in some nearby and in this city. And on that time, even engineer used these lightweight blocks due to the durability as sustainability. As you can see, it still is there. In this slide, I wanted to show that there are well-established standards, that there are very good recommendation how engineer can use this concrete in structure parts. I am not maybe going through in the detail, but American Concrete Institute ACI 318 is, and also Australia standard and some other standard, they well established using the lightweight aggregate concrete in structure. But honest talking, long time I'm working on the structure concrete since now around maybe 20 years. I can see that there is a hesitation to use this type of the concrete by the architecture and also especially for the design engineer. To be honest, I don't know how, I don't know why there is this hesitation. Maybe one reason is they are not well educated about, and they don't know much about this type of the concrete, which is not really complicated. But this concrete has huge advantages. As you can see, some developed countries, this concrete was used long time ago. For example, you see in the US, 1991, this high-rise building. In this high-rise building, in this tower, this compressive strength of 62 MPa. Practically, we consider it is a very high concrete. Used for the column and for the slab, not for foundation. And in Australia, is another building can be seen here. 1967, this concrete was used for structure. As another application of this concrete is a bridge recently was opened for the public. I was involved I had a chance to be involved in this project to develop this lightweight concrete, but it was not as interest of the engineer, but it was a must to use a structural lightweight concrete. Here is these are the lightweight aggregate. Those are, I mentioned, it is artificial manufacture. Is not available. It is imported material, so can judge. Of course, the 1 meter cube concrete by this aggregate will be much more expensive. But in some project like this bridge is they call it is named as Terengganu Drawbridge. Terengganu is a city in the Malaysia, and then Terengganu Drawbridge in this bascule, to lift this bascule from each side, this portion will light. And as you can see in this figure, this portion is fully lightweight concrete, but is white color. Another part are in the dark color. Dark color is showing that it is a bituminous asphalt, but in the white color are fully lightweight concrete. Even the designer, due to the importance of the dead load, designer didn't allow to the contractor to top up even 5 mm bituminous. It must be fully the live concrete because of the weight. And here, these two part of the construction is this bridge is, they call it a sky bridge. There are 2 sky bridges here and here. Live concrete also was used here. I want to highlight this issue that in the important and national scale project, this concrete was used. But my aim is we have to, for the zero energy building and for sustainable construction, this material should be as a common material for even normal building and high-rise building. I am showing here another, my experience is to use this concrete for extension building, for an old building. In the red color, you can see here is extension part. The concern, this building was more than 35 years, and the concern was extension on that soil may cause some settlement, and there will be maybe a risk of the crack between the new parts and the old part of the building. That's why to make a lighter structure, we use live concrete. You see the extension on the bottom figures, and then but the concrete, to make a lighter structure, we use the live concrete. Another, maybe showing another benefit of the structural live concrete is saving the material in structure, in foundation. This figure and curves was developed 1977, long time ago, to highlight that, scientifically highlight that how much application of this concrete significantly improve, significantly have saving and on the construction materials. Let's say if we use these graphs, we can estimate that if we use a live concrete with a density of 1,650 to 1,700 kilogram per meter cube, as we know that normal concrete has a density of about 2,400 kg per meter cube. Instead of the normal concrete, if we apply this concrete in a high-rise building, we will have the 35 to 45% of the saving on the slab foundation. It is a long time ago, maybe a book that always is my reference. It still is, to me, is information are fresh, because after that, not much developed practically. I myself had one study by my group and our team. We simulated a building, 15 floors building, and this is the typical plan for each floor. We suppose that in this building, this building is a seismic zone, like for example in the Turkey is a seismic.
Okay, we cannot hear Payam, unfortunately. Okay, we will continue with Benjamin. Okay, now when he returns to the session, he will continue. Okay, now Assistant Professor Benjamin Durakovic will give a speech. Benjamin is a member of the Forum's International Board. He is working at the Faculty of Engineering and Natural Sciences in International University of Sarajevo, Bosnia. His research interests include energy storage using phase change materials for passive building design and building energy efficiency. He is the author of a book titled PCM-based Building Envelope Systems, Innovative Energy Solutions for Passive Design. His presentation is regarding PCM-based technologies for building application. Yes, Benjamin, dobrodojli. We all are waiting for your address. The stage is yours.
Thank you very much for the invitation and giving the opportunity to share my piece of my research actually in this forum. So I'm going to share my presentation now. And,
Is there a problem, Benjamin, about sharing?
actually, it takes time to share it.
Yes, we can hear you.
Can you hear me?
Exactly.
So I click on share and I'm waiting to come up.
If you can use earplugs, Benjamin, there's some noise.
Yeah, I don't know where I lost you. I'm really sorry to hear.
Okay, welcome, Payam. The stage was of Benjamin, but we can again continue
Okay.
with you, okay? You
Yeah,
can
so
continue,
sorry.
Payam.
All right. I don't know in which slide I lost you.
Benjamin, we will continue with Payam. He returned. Okay?
Okay, okay.
Okay.
Sorry.
Okay, please,
Okay.
Payam.
Right. Okay. I don't know where. Can you just let me know where I lost you? Just around.
Show the slides.
Oh, sorry. I just I screen
You
right.
can share your presentation.
All right. Yeah. Just. Yeah. Hello.
We can hear you, Payam. We can hear you.
Okay. Is it okay? I think
Okay. There's no problem. Your presentation is ready. Okay. You can go on.
Okay. I go faster. Okay. I lost time. Don't take other speaker.
Payam, go further.
Okay.
Payam, can you go further with your slide? Further. Yes.
Okay.
No, go back.
Great.
Go back. I remember that it was, you finished this and you were going to the following.
Okay. Thank you very much.
That's what I remember.
Okay.
I don't know if others have another say.
Sorry again.
Yeah, you talked about slide 16 already.
I'm going faster. I was explaining here the benefits of using structured concrete. How can it help to the sustainable construction? We will have a significant saving on the material used in the building. And then here I just explaining my experience based on our simulation, how application of the structural concrete reduce the concrete and steel used in the building, and significant maybe reduction on the cost of the total construction. As an energy concern, usually food, water, and energy is very important, and security in this area are important for everybody and all the societies. So as a concern of the energy, we see the in the residential building, we have a significant use of the energy. Yeah, as you see in the US and in the our climate in Malaysia is as a tropical region. Residential is 5.7% and commercial sector is 8.4%. Is energy will be used in the Malaysia. In more detail, in Malaysia is for air conditioner. We have a significant use of the air conditioner in the in hot and tropical region. Air conditioner and ceiling fan. In this our climate, aircon has a significant role for thermal comfort, to provide a thermal comfort in the envelope. If we on the air condition for a space, something about 1,000 to 1,500 kilowatt hour per year, we need electricity. However, once we off the aircon, maybe even at the room I'm here in my office, when we off, can say very soon it will get hot. Reason why? Because we are not using the low thermal conductive material. It is very essential that at the time of the selecting of the material from the architect or engineer, thermomechanical efficiency of the material to be considered and the best material be chosen. For example, for thermal barrier material, at the same time can select some material can have a load bearing capacity and also thermal conductivity. This role can be followed by using the structure lightweight concrete. Using lightweight aggregate in structure concrete. Using lightweight aggregate in structure concrete significantly reduce the thermal conductivity. A research conducted by Rio and his team show that if in a building constructed by lightweight aggregate concrete, 15% reduction of the heat energy will be reduced compared to normal weight concrete. So it will be significant. But if this building is located in the Europe countries, which is cold regions. But what is the mechanism of saving the energy in the structure level concrete? These are the lightweight aggregate inside our porosity. This porosity, because of the air conductivity of the air is very low, so using this aggregate instead of the normal aggregate will reduce the thermal conductivity. And this is a microscopic image of the inside of the lightweight aggregate. As you can see, for example, in the right side of the figure, this is the lightweight aggregate. There you see a lot of the porosities, and a bit right side of this figure, there is a solid figure. This solid is come from the cement matrix. Cement matrix is very dense. That's why conductivity of the heat will be very fast. But this porosity is a good barrier for the heat. That's why using the lightweight aggregate inside the concrete will reduce the thermal conductivity. As our latest project is we monitor and calculated the heat cooling loads in a building, in a high-rise building with 29-story building. This is the real building with a typical plan of each floor in right side. This building, we supposed to use a structure, we call it shear wall structure. In these structures, we are using the load-bearing RC wall instead of the column. It is a quite common type of the structure in the high-rise building. And then we see the result, how much energy and the cost was reduced. In the right side, there are different type of the live aggregate. Unless there is a one concrete is normal way concrete, we call it as a comparison. The rest all are different type of the live aggregates concrete. If we suppose that to use the live aggregate concrete instead of normal concrete, based on the definition here as a GBI certified EOI for the low energy building, which is 150 kilowatt hour per meter square per year, the only material can fulfill this requirement and pass this indication is just live aggregate concrete in different orientation. And we suppose that we are using this structure in different regions, let's say in Malaysia, in Saudi Arabia, in Turkey, and in Europe. If we apply this concrete, so in our region, so we are sure that we can pass this indication. And as a cost for different type of the region, as you can see here, we calculated the cost and energy saving. In Malaysia, if you use a structure concrete on that specific building, something about 4%, the energy will be reduced. And then in Saudi Arabia, if the same building be located there, is something about 6.5%. In Turkey is something about 5%, and in the cold region like in Europe is much more significant, something about 12.3%, as was specified by other researchers, which they reported it is a 15%. As a cost also, the cost of the electricity and the energy was highlighted in different regions. As you can see, is maybe in the cold region is much more significant. I just finished my slide, but as a conclusion of my slide for application of structural concrete is, unfortunately, our engineers are very hesitated to use this material. To me, to save our building and saving construct a sustainable construction and follow zero energy building, education should come in the undergraduate level, and our engineers should be trained. We faster follow this sustainable construction and significantly save the energy in the building. Thank you, and sorry again I lost you because of my internet.
No problem, Payam. Thank you very much, Payam, for your nice presentation. You both very clearly reflected the importance of structural material viewpoint for energy efficient buildings, and you stressed the significance of the proper selection of structural materials such as concrete with lightweight aggregate.
Yeah.
Thank you very much again. Okay, Benjamin, are you ready?
I'm ready. Let's try again.
Are you ready?
Yes, I'm ready.
Okay, you can share your
Can you hear me? Yeah. Okay.
Yes,
thank you very much.
we hear you, but your presentation is ready.
Yes.
You can share it.
Yes, sure.
Benjamin, if you can't share your presentation, we have your presentation as well. Okay, it's ready. Okay.
Is it coming?
Okay, we see it.
Okay. So, can you see it?
Okay, no problem. Okay, you can start,
all right,
please.
So, thank you very much for the invitation and to this forum. I'm trying to introduce actually the latest research in the field of application of PCM materials in building technologies for basically for energy storage and energy efficiency of buildings. Here are just brief outlines. What I'm going to actually focus is actually understanding the PCM materials and its application in building the structure and components. And especially I'm going to talk about, not especially, but a little bit about the application in the glazing systems and free cooling system. Also, what is well known, and it's kind of been using for a while, application in separate heat storage modules that been used along with active heating and cooling systems in buildings. So it's well known that buildings are consuming up to 40% on the global level of the energy for heating and cooling, and usually the energy being based on non-renewable energy sources, and in that case PCM materials would play an important role in reducing building energy demand, and also that it is also important to reduce non-renewables like fossil fuels for other things and preserve it for the other things like for lubrications, etc. And general world trends are reducing building energy demand and preserving non-renewables, and through the introducing design concepts. So why PCM materials are so important? Because they use latent heat for the storage of energy in building. So due to high density of the energy per unit of the mass, it is very useful and can store a huge amount of energy on a small place, and especially it is important for the lightweight buildings. Also, it has an important role in zero energy building, and so when we talk about zero energy buildings, we can, and PCM materials, there are two things. So the first thing is reducing building energy demand, and then another thing is producing energy and actually turning the building to the mini power plant. So PCM are in large quantities available and used in passive as well in active strategies. So from the theory, what is actually, how to understand the difference between sensible heat and the late sensible heat is when we heat a body, from temperature T2, for example, so the heat accumulated in that body is considered as sensible heat, while the latent heat is the heat when we heat a body, we don't actually see the change temperature in the body. So the best example is the melting of the ice. For example, if we have ice that has the temperature below zero, we heat the ice, and then the ice reach the 0 C, and at the 0 C it starts melting. The more the energy to the ice, and the ice it continued melting, but still it is 0 C. So whole heat pumped to the melting to the ice is considered as latent heat. So in this here we see that, let's say, sensible heat in the first case, the area under the curve represents the sensible heat. But in this case, with the PCM material, the area under this red line is considered the latent heat. If the ice, for example, is melted completely, and we continue heating the water from temperature 2 to temperature 3, for example, the area under the curve is considered sensible heat of the water. So we have certain materials also that can be used using this principle and can be applied in the buildings. So once the cycle over the day is the reach maximum temperature, it starts as cooling, and then actually it goes back to the. So comparing this diagram with the regular or common material applied with the building, it's supposed to look like this. The material, construction material in the building usually heats up to the maximum temperature and then cools down over the night to a minimum temperature. So that's a cycle. So the temperature difference, how it prevents overheating the building, is actually the peak temperature difference between the material and the regular construction materials we use today. So what actually we do here, we have two things, reducing peak temperature and extending the hours of in the vicinity of the melting temperature that contributes thermal comfort in the building and preserves the building over the heating using the energy storage as a latent heat. So basically we have three groups of these phase change materials. So those are organic materials that are based on the paraffins like fatty acids, alcohols, etc. And inorganics that are the oldest ones we've been using for the building applications and the storage are salt hydrates. And some specially made eutectics materials that are mixture of the previous two or mixture by itself. When it comes to the diversity of phase change materials with respect to the melting temperature and the melting energy required to melt the PCM material, there is a huge variety of these materials. And the melting temperature ranges from the 0 to 100, almost 100 C. So what is important and what is applicable for the building application for passive house? If we use, we have interest in the melting temperature between 20 and 32 C. It's very narrow range when we consider these materials. And then what goes to this range are some fatty acids, alcohols, and paraffins. If we see that paraffins been most frequently used in the research, they've been actually in the vicinity of 200 megajoule per cubic meter of energy can provide actually. So some materials above this temperature range between 20 and 32 are used for active systems, for heating in active systems, and usually for modulation in certain containers, and then below for cooling in active systems. And here, when it comes to application of phase change materials to the buildings, it started far back in 1958 by MIT engineer Maria Talks. She tried to design a house that been supposed to be used PCM materials. It was salt hydrate at the time, and she tried to use solar to capture solar energy within PCM materials and distribute the heating of the house. It's known as Dover's house, and that was the place when the house was placed. So the system been used for 3 years, and after that, since she used salt hydrates, the problem was with containers, and the corrosion started, and the leakage occurs, and then the project stops at that point. So during the energy crisis in 70s and 80s, more attention, as you see here in this diagram, paid to the PCM materials again, and then some papers been published and research been published at that time. But since 2000, today, very rapid increase in research and application of phase change materials within building environment. So the parts of the globe, that China is the leading one with this research. United States, majority are these published research, and then are coming to the hot climate countries actually, and they use solar radiation to capture energy, store within the PCM material, and use it for the later usage. So in passive concepts, we can use for heating and for cooling also.
Benjamin, it's your last minutes, please.
Yeah. Okay, I was sure. So, in the cooling passive thermal mass as a PCM is used in the free cooling and forced as well, and can be applied in the structure like floors, walls, ceilings, even though in windows, interchangeably over day and night, and in application increases thermal mass of building, and that prevents overheating. Also can be used with a trompe wall for heating and cooling over the night as well. With free cooling, so the fan moves the stores in the ceiling and charges over the day and discharges over the night. With the glazing system, as we see, that is in the glazing system can be it's not applicable with the high demand for the light, but in some maybe less demanding for the light space, yeah, it can be used. It is kind of semi-transparent, but when it is melted completely, it is completely transparent. Up to 20 to 25% of energy saving can be utilized by application of these materials in the circuit building. And let's say for the building envelope particular, it's about 70-23, 76% for daytime cooling, low demand at floor 89% during cooling demand is reduced. And in separate heat storage devices can also be applied as basically capture in the solar collector of the solar heat, store the heat in the heat bank, and from the heat bank can be used with the heat transfer fluid, the heating the space inside. Also can be micro encapsulation or micro encapsulation. This is type of use with building like concrete, mortar, bricks, and the macro encapsulation can be used for let's say with modulation and active system as well.
Benjamin, can we
different
conclude
type
it,
of
please?
enhancement. Yeah, sure. I'm going to conclude it. Okay. So generally can be enhanced thermal characteristics of building, widespread application, and it's very hot topic for the research, and it is a common material, could be common material in the future building construction, especially in passive housing, and reducing energy demand. Thank you very much. Sorry for using more time than it is. It should be.
No problem, Benjamin. Thanks a lot for your detailed speech indeed. As we know, to reduce the building energy demand, the thermal energy storage plays a vital role, and in this context, PCM has a significant place both in theory and in practice. Thank you again. Lastly, Ms. Maike von Krause-Kohn will make a presentation. Maike is working in national and international projects on municipal heat recovery, quarters, and renewable heating and cooling in German Energy Agency in Deutschland. Before joining the agency in 2019, she worked as a research assistant in the Technical University of Berlin at the Department of Mechanical and Power Plant Engineering. For several years, she led energy seminars on the integration of renewable energies in buildings, electromobility and heat, electricity, and cold storage technologies. Now, the title of her speech is Energy Efficient Buildings in the Heat Transition. Herzlich willkommen, Maike. We started the forum on Wednesday by a speech of a lady from the UK, and now closing it again with a lady from Germany, you. It's a great honor for us. Now all participants are waiting for your presentation. The stage is yours.
Thank you very much. I will try to share my screen. So can you see my presentation?
Not now, but it can take a few seconds.
Okay. I hope I took the right screen.
Okay.
So do you see something now? It worked when we tried it. I hope we can manage to do. Do you see a presentation?
No, not now.
No? Oh. Okay. It is allowed. But the internet connection is all right at my place. I don't know. You can hear me well, right?
Yes, we can hear you, but we cannot see your presentation.
Okay, I'll try to do it like this. Do you see something now?
No. Okay, it comes.
It comes? Okay.
Yes.
That's good. So, do you see a PPT?
Yes, we will see your screen now.
Okay. You see it full screen?
I am seeing your screen. Okay, no problem.
You see the first slide of my presentation where it says energy efficient houses in the heat transition?
But Maike,
Yeah.
you can activate your PowerPoint presentation.
Yes.
We just see your screen.
Not the PowerPoint. Do you see the agenda?
No.
Oh.
No. We just seeing a white screen.
A white screen? No, that's not what I wanted. Okay, I'll try again on some technical issues today. Do you see the presentation now?
Okay. Very good.
Yes?
Excellent.
Okay, finally.
But
So,
if you can present as soon as possible,
yes, of
we
course.
will happy.
Yes,
Okay.
I will be fast today. So, energy efficient houses in the heat transition. I will first tell you about the German Energy Agency, where I'm working as an expert in integrated quarters. And my main topics are the heat transition and energy efficient houses, innovative technologies, and there especially the storages. So some facts about the DENA. We are working with the management and a lot of partners that are mainly the Federal Republic of Germany, and there are some federal ministries, main federal ministry for economics and energy. And of course the KfW group, that is a bank in Germany that gets a lot of credits and so on. And if we look at our main office, it is in Berlin. I'm actually in Bremen because, as all of you know, we have home office most of the time. And we are over 50% women. Here you see one of them. And we have more than 240 employees at the moment. And ongoing projects, more than 90. One we are doing at the moment with Turkey, and I'm there in a team where we look at geothermal cooling, and others are looking for example, wind turbines onshore, and I think we did something on offshore as well. And yes, it's very interesting to do these international projects as well as our German projects. So when we did our study last year for your department, we looked at the renewable sources and conversions if we look at heat and cold, because as the other speaker before hand said, it is a great part, and I think it's actually in cities more than 50% of the energy that is used is heat and cold, and it's getting more and more because of the heat crisis. So we need to look at the renewable sources and the conversions. And here you see in blue the ones that are needed if we need cold, and in red you see the ones that are needed if we want to heat something up. And with the grid, there's not just meant the electricity grid, it is also meant the heating grid, the district heating. And if we look at renewable power, we can use it directly or via compression, for example. And for Turkey, there's especially the industrial heat waste, very interesting. The solar thermal energy is used quite much already, and we have a lot of geothermal energy, especially in the regions next to the sea, and in some other places, of course, as well. And we want to use biomass, but with biomass, we always have to see that there's a big gap between biomass that we could use to feed other people and biomass that we could use to burn it or to make other products out of it, to heat or get cold for our departments. So we could also think about hydrogen or fuel cells, and of course storages. If we look at the heat transition, we always have to look at district heating and cooling, of course. And in Europe, we talk much about the 4 generations that you see here. If we look in the last centuries, there were temperatures even above 200 degrees. That is so much and too much losses. So we think that we should go down with temperatures. Of course, if we have high temperatures, for example, from waste heat, it is always good to use it at that temperature and use it directly in another process, or use it to heat a district heating grid. And of course, we need to get higher efficiencies. We have a lot of ongoing projects in this topic, for example, in the Ukraine or in Russia, where we look at the district heating grids and talk to them and trying to find solutions how to make them more efficient. But what has all of this to do with energy efficient houses? If we look at a grid, we always have the prosumers and the consumers, and they need these electricities. Of course, you could just apply them to one house, but sometimes it gets even better if we use it via grid, because we have more consumers and prosumers and more flexibility in the grid, and a longer way is sometimes good to not lose that much if it's not directly consumed by one party. So here you see what we think about the 4th generation that should be ready in 2050. And there we want to have, for example, CHP, cold and hot storages, heat pumps. We want, of course, all the renewable powers that you see above in the line and potential future energy sources and things. And in Germany, we have a big power to heat and power to hydrogen action now, and I'm very interested in seeing what comes next. So if we look at the heat transition, we think, okay, it's of course a part of the energy transition, and the heat transition does not work without district heating. This is a citation by Professor Dr. Eckhard Ritterbach, and he said that the district heating does not work in Germany, especially anymore, without heat storages. And I think what happened here with all the renewable power in the grids and so on might happen to other countries as well. So maybe take a look at Germany and look what we need now. Maybe you can think about it earlier, and then you will have it at the right time. And yes, we are working on thermal storage integrations at the moment in one of my projects. There we look at what do we need. It's a project that is running with the International Energy Agency and the German DLR. and we try to find out, okay, how can thermal energy storages be applied? They can be applied, of course, directly into a house, like we saw in the last presentation with the thermal storage, for example, PCM material that is in the house, but we, as I said before, look more at the grids. And there I especially want to inform you about two relatively new technologies. One is from Kraftblock. It is a storage that is, for example, used in the steel industry, and one is from Siemens Gamesa Renewable Energies. Sorry. And it was built in 2018 up to now, actually, because it's the first of its kind actually in the use and giving energy for over a day. Up to 24 hours, they say that they can provide energy. It is a rock storage blown by air and then converted by a heat facility into hot water again. And yeah, it can give energy to a lot of cars, for example, if they need electricity afterwards, but it is also able to provide hot water. And yes, that is a quite interesting, flexible technology. You see it here again. You can put electric power or thermal power for charging, and then the input for the thermal energy storage would be thermal power input, and then you can get thermal power out again, and via the discharge you will get thermal power or electrical power. And I think that is a very good opportunity. They call it Carnot battery, and it will be an opportunity to take all the surplus energies and all the surplus hot steams from industrial processes or elsewhere. And I'm really looking forward what it might be in some years. If we look at the German Energy Agency again, we have a building report that is nearly every year published. You may get some interesting facts there if you want to have a look at someday. We have a lot of statistics and analysis, and at the moment we are writing a chapter about heating and cooling as well. We are not sure if it will be published in the beginning of next year, when exactly, but yes, I think it might be interesting for some of you. And if we look at energy connections, CO2 and life cycle, we have this diagram. I was very happy that the first speaker in our group told you already about the nearly zero energy houses. You see them here in the blue line. We think even better would be a plus energy house, where during the phase of the usage, here you see it in the operation time, approximately 20 years, it will even share more energy than it was needed to build up the house. And during the partial renovation, there is some energy used, of course, but during the next 20 years of the usage, it will get energy out of this house again. So this is a project we do a lot in China. We had some projects about energy efficient houses in Germany as well. And for example, in Berlin, some of you may have visited it when they had come there. Next to the Technical University of Berlin, there's a Energy Plus house, and it's interesting to see what they did about windows that can change color if the sun is burning, and so that it doesn't get so hot inside. And they did some social studies in there as well. Yes, we like to show people these best practice if they come to Germany after Corona, hopefully again. And yes, if you are interested, just write us an email afterwards. And yeah, I wanted to show you something about solar cells, because I think they are a good opportunity for energy efficient houses. Here you see the three main categories. I could go deeper inside now for the advantages and disadvantages, and you will always see a picture to understand what kind of solar cell it is, because we see them on a lot of rooftops already. This is a silicon solar cell with monocrystalline cells, and it has a very high efficiency, but if it gets, for example, partial shading, it will get a lot of losses. This is better with thin film solar cells, and if we look at the polycrystalline solar cells, they have a little bit low efficiency sometimes, but they, as well as the monocrystalline silicon solar cells, they have a long lifetime, over 25 years, and that makes them very affordable, because you, after like 4 or 8 years, depending on the electricity price in your country, will make a benefit out of it. And especially for places where there's no electricity, it is an option, of course. And if we look at the thin film solar cells, they are very nice if we look at new buildings, or if we have to repair something, because you can use them even if temperatures are very high. They are very homogeneous, they are flexible, and can be very good integrated into a building like a roof. And they have a great potential still to improve their efficiency, as you can see here. Now we have a CIS efficiency of 16.3%. And yes, there's, for example, the cadmium telluride and the CIS that have a low energy return time. But although we have to look at the materials, and some of them may be some kind of toxic, but of course it's all surrounded. So yes, they can be used, especially in cold regions. And if we look at the organic solar cells, they are very, very new, and they have very low efficiencies, but I'm really looking forward what it might happen later, because there are some models that can be applied like some kind of a very thin texture that can hold even on a wind turbine, and that is quite a big space that is not used at the moment. But of course it will get electricity out of it again, so you may have a look at if it's very good in your energy system, because where there are wind turbines, we have some problems with the frequencies sometimes. But for universities and other buildings that are already built and have some very low weight issues, that you can't put so much weight on the rooftops, it might be a good option. But what can we do with this solar electricity? We can cool, and that is my last slide for today. Here you see an example of a split model for cooling, and yes, I think in a lot of countries it will be very important in the next time to have a lot of cooling, and it shouldn't be done by fossils. So why don't use cooling? Here's one example. You could use it to compress, and maybe use optionally of storage, and then get the cool out of it. Thank you very much for your attention. And yeah, I will stop my presentation now. Hello, I can not hear you. Your microphone is off, Shady.
Sorry, I forgot about it. Thanks so much, Maike, for your presentation. It's a great honor to see a specialist from German Energy Agency in the forum. I think probably the most important part of zero energy buildings lies in the storage and usage of renewable energy. Thanks for touching upon and explaining these issues indeed. We can now take questions from our listeners. The first question is for Shady. Shady, the first question is for you. I'm reading it. Does the construction of energy efficient buildings require the specialization of a worker, or does any worker fulfill his own trade without knowing anything about energy efficient buildings. Shady, actually, the workmanship is maybe the most important component in the construction process and on the product quality, as you know. What do you want to say about the question about workmanship?
In most countries, there are trainings and certification for the different disciplines like plumbing, roofing, wall bearing, construction, all the masonry and so on. But unfortunately, in most countries, there is no training and certification of trained workers for two aspects, airtightness and insulation. Unfortunately, those two aspects in many countries do not have a certification, so the worker is not certified. And my advice is that vocational training in any country that is adopting energy efficiency measures should really focus on, first of all, certifying these jobs and certifying these workers with a focus on insulation, people who are installing insulation materials, and people who are applying or assuring airtightness. Unfortunately, in most countries, we discover that the least skilled labor and the least educated labor, and most of the time they are foreigners. In any country, whatever its economical status, you will find that in construction sites, there are foreigners, even if the country is a middle-income country. And those foreigners are most of the time not trained, and it's a problem. So my answer is yes. You must invest, first of all, legislation. The country must have a certification for those workers. And then based on this certification system, you can make sure that those workers, they know what they do. I just give you a little small example. The person who is placing a thermal insulation is not the person who is placing an acoustical insulation. You know, acoustic is something else. And this is a big conflict on site. People think that acoustic insulation is thermal insulation, while they are not playing the same role, and placing them in a wrong order or in the wrong, not respecting the right detail, can jeopardize the whole performance, especially that cities are getting more dense and acoustic regulations are getting higher and higher. But that's my answer simply.
Thanks for your answer, Shady. Now there's a question for you, Payam. I am reading it. What can be done to eliminate the barrier in front of the fact that industrial practitioners and academicians usually cannot meet in the same point simultaneously, as you said in your presentation? Payam, this is because you say we would introduce the lightweight concrete to the engineers to further apply it. The question asks, what is the motivation behind it? Actually, practitioners do not trust academicians, or they do not aware of what academicians say, or they are in front of academicians about views on industrial applications. What is your personal opinion and view?
Yeah, you're right. Very right question. Expected to have a discussion from the who are expected to use it, because when you describe by document, a strong document, that how much we have a benefit, it make attraction. But there is not, once this presentation and talk and technical issues come from somebody from the university, usually there is a big gap between, at least in developing country, the big gap between the universities and practitioners. They call it, you are fully on the theory. But I myself came from the industry to the university, as I like too much to do the research and then develop it. And at the same time, I have some project. The project I show in my presentation in Terengganu Drawbridge is, to be honest, it is a very big project and huge responsibility. But it is the biggest project I applied this type of the material in this big project, not only in the Malaysia, I think maybe in Asia. But how we can solve this problem? As we can see, I have much more project that I can describe. Long time ago in developed country, it was used because of the huge benefit. But to me, one reason we are not applying and our engineers are not trusted it is because we don't have enough education. Education must come from the undergraduate degree. I can see in many of the syllabuses, they are not. This concrete is considered as a special concrete. A special concrete means that needs somebody very expert on it. But to me, is no need, because already established long way ago. This was established from the standard. We have a very certain and clear standard, but need to our engineer. At the beginning, they have to train in the universities, and the future generation, especially in the, for example, talking about in the Turkey, you have a lot of the natural and resources, and I don't think you have an artificial lighted aggregate, but it can be purchased from the Europe, in Iran, nearby there. It's to be, I think it will be very reasonable price. So, but our engineer don't know. But once don't know, it will be a. So we have to start from the undergraduate degree and then the new engineer.
Yes. I think industrial practitioners has a lack of awareness on lightweight concrete. They imagine it as a non-strength material. I think.
Just add one thing. That's why in all of my presentation, at the beginning I start to open the mind. What does mean lightweight concrete? Something is not really. Many people don't feeling that it is not load bearing, as it can be shown in the porous concrete for partition. But structural level concrete totally different. Can be load bearing significantly. There are a lot of the example in many countries other than in maybe in Asia countries. I hope one day the engineer universities start to do education, and those are interested. The current engineer also easily can learn about it and then touch one time and experience this concrete. And then I think there is a scare of using it. But when you see in front of this scary way feeling, there are huge benefits that I think many of the developer and investor would like to use it.
Yes, maybe industrial practitioners should see and understand it, for example, in public projects of governments. Maybe that's why with this way they may be convinced.
Exactly.
Okay. The question is for Benjamin. Benjamin, I am reading the question. Organic phase change materials, in particular paraffin waxes, present some flammability hazards, which raise some concerns about the fire resistance of products where this material is applied. What can be a solution against the disadvantage? Is there any method to resolve this?
So that's right. So organics are flammable, and that is, I would say, it is a limitation of application of these materials for certain applications. So I would say basically the places and the systems that we don't have concern for flammability, we can apply it. It's combination with let's say separate heat storage devices, that would be the most optimistic application of these materials. Also, the other materials like salt hydrants have other problems. They are kind of aggressive for the containers, and then that is the limitation of application of salt hydrants in certain applications. So it's kind of trade-off. So we should assess and be careful if the application requires some high standards regarding the flammability. It wouldn't be recommended to apply in such applications.
Okay, thank you, Benjamin. And one more question is for Maike. Maike, I'm reading it. What can be said concerning the cost benefit of solar cells in building integrated applications? It means, is there any numerical value in your hand, for example, in terms of life cycle assessment? What is the payback period time in Germany, for example, on an average, as it is, of course, can change depending on the location?
Yes, it is depending very much on the location, and it depends on the contract you get. We have here now a new concept that is called power purchase agreements. I don't know if you have that in your countries too, but it's a way to make the PV panels affordable. And it is like a contracting system, and I think that would be a good option. I can't say numbers here because there are very few projects ongoing at the moment, but as PV panels with monocrystalline and polycrystalline cells did have such a good learning curve, I really hope that the thin film and the organic ones will have one as well.
Is there any financial incentive in Germany in this regard to foster its usage in industry? I don't have any more information about the costs on this point. I'm more in a technical way. I'm an engineer, so I'm sorry for that. But I can send this question to my colleagues if anyone wants to send me a question. It's just my name without the minus between my two last names, and then at DENA.de. And then I can send it to the other colleagues that are more into economics. Okay, anyone can contact with you through LinkedIn. Okay. We exceeded our time, unfortunately, very, very much indeed. And I would like to thank you. We would like to thank our 4 speakers, dear our listeners. Thank you too much, Shady, Payam, Benjamin, and Maike. You all have made a great contribution to the forum by sharing your views and presenting theoretical and practical applications on zero energy buildings. I think they are very precious for our participants. Now we can terminate both the session and the forum, as this is the last session of the forum, as we also experience the environmental alarm of the nature in our daily lives instead of hearing them just on the media. We should immediately take initiatives as the industrial and academic shareholders. Thus, I think we fulfilled our responsibilities indeed. To achieve this, we have learned and discussed on zero energy buildings throughout 5 days, about 50 sessions and about 140 speakers from 35 countries. However, this is not a one-time solution, one-time shot and initiative, but an ongoing effort on awareness and knowledge transfer. Therefore, please note that all our participants that the subsequent Zero Build Forum will be held in the next year. See you in 2021. Bye.
Bye. Thank you very much.